Good morning, all. It's my honor to introduce today's first session resource person, Mr. Dhineshkumar S, Senior Project Lead, Lantrasoft Private Limited, Coimbatore. Dinesh Kumar is a process and result-oriented professional with a demonstrated history of working in the information technology and services industry with nearly 10 years of experience in healthcare, insurance, operations, manufacturing, and logistics, then supply chain and product development. He is currently working as a project lead in Lantrasoft Private Limited, Coimbatore. Also, he is pursuing his doctorate in Vellore Institute of Technology. His area of research is artificial intelligence and machine learning. He having experience in wide range of technologies and frameworks. With his wide range of expertise, he is working with multiple clients in both offshore and on-site. With his 6 years of teaching experience, he conducted many technical workshops, faculty development program, technical seminars in various leading colleges throughout the India. He is also on active board of studies members in many leading colleges in India. We welcome you, sir.
Yeah, yes, man. Yeah, thank you, sir. So, am I audible and visible, sir?
Yes, yes, sir. Yes, sir. Yes, sir.
Yeah, thank you very much. Thank you very much for the brief introduction. So, without much delay, I'm going to share my screen. Can you able to see my screen, sir?
Yes, sir.
Okay. Yeah. So, good morning to one and all present here. Myself is Dinesh. As they already said, I have nearly 10 years of experience in IT as well as 6+ years in teaching. So, I have a passionate in teaching. Also, I'm working in an industry. So, also I'm pursuing my doctorate in VIT Vellore. Currently, my courseworks are done, and I'm now implementing the project and submitting that one. So, that is a quick introduction about myself. And the topic we are going to see today is factor analytics. So what exactly the factor analytics is? Can anybody quickly tell me? Actually, I want this session to be interactive so that at the end of this 1 hour plus, you learn something and I also learn something from out of this session. So I would like to have this as an interactive session. So what are things you know about factor analytics? Can anybody quickly brief me on that one? Or it's like it is a new to you. So what exactly your status with regards to the factor analytics?
Simultaneously, sir, excuse me, sir. Simultaneously, you will view the chat box since some participants are responding in the chat box. Okay.
Oh, really? Okay, okay. Actually, okay, sir. Okay, yeah. Okay, yeah. So yeah, it is input variable analytics. Any other sessions like what exactly factor analytics is? Yes. When I studied about factor analytics, it was very new to me, and it was like I was curious in knowing what factor analytics is and how things are progressing. So, any idea on what factor analytics is? Okay, yeah, that's fine. So, in general, factor analytics is nothing but it is method for data reduction. So we know there are multiple methods in data reduction. So before that, I would like to base set expectations. Like so, initially I'll explain you about what factor analytics is and how it is working and what are things you need to take care about factor analytics, etc. Then I'm going to switch gears from theoretical part to the practical part. So that is how I created the agenda for this meeting. So what exactly factor analytics is something that it is form or it's a type of data reduction, and it is mainly used to take many variables and explain them in the form of factors and components. So I'll explain you about these things in detail. And about factor analytics is it is nothing but a correlated variables. We group it, we separate it from other variables, and we make decisions out of those variables. That is what we call it as factors. So where exactly and you can ask me, okay, are we using factor analytics in the industry? Yes, we are using factor analytics in the industry. How we are using factor analytics? So factor analytics is nothing but, as the name itself suggests, factors are nothing but it is like unpredicted or uninformed data. So I'll tell you a real scenario where I personally implemented this factor analytics in one of the project. So we had, when I was working in Cognizant, initially I had experience with Cognizant, and I joined a startup company in Coimbatore. So when I worked with Cognizant, my second project allocated to me, it was a project that was for a UK company. And then it is like a end-to-end solution for an organization. And we need to provide, it's like we need to create one module. I was into 3 modules, and out of which one module, we implemented this factor analytics. So you can think of, I started my career in 2011, and now it's 2021. So it's almost like I started the project 2012 or 2012, I think. Yeah, 2012, I worked on this factor analytics. So what exactly we did in the project? So the requirement is very clear. The requirement is very clear. We need to create a module. In that module is pretty much for the HRs. And if you see, HRs is pretty much deal with hiring purposes. So HRs work with the hirer, who is the employer, and the hiree, who is the person who is coming for the employment. So they deal with those people. So it is the HR's responsibility to take a decision, okay, whether this person is suitable for this job or not. So that means you can ask, okay, whether managers or the person who is interviewing them, will they do any job? Yes, they do. They rate the hiree with certain factors, like for example, whether the employee will, the hiree will fit for the organization. It's how is his attire, how is his mannerism, and so they rate it out of scales. So from you can name it from 1 to 5 or 1 to 10 or 1 to 50. You can name those scales. So HR's job was like to get those information also out from the hirer, the manager, or the people who is interviewing them. So as we know, in the industry, the interview is not only related to a single round. So it's like from the base interview to technical to HR, and then we have product managers, and then in some companies, CEOs also will have those interviewing capabilities. So it will take from 1 round or maybe 5 rounds, or in some companies like ThoughtWorks, it is like 7 rounds. So each and every round has some outcome. So for example, their requirement is they have 5 rounds of interview, and they need to get the questionnaire answered from those 5 round interviewers. So what they did is they collected those information, combined it, and we applied factor analytics on top of it, and we found, okay, as a software, we are giving output to them, okay, whether this employee is fit for the organizations also. So even though the manager or deputy manager or your CEO or anybody accepts, okay, this guy or this person is fit for the organization, so their intention is they have to make some machine learning embedded on top of it, so that the computer, the software also tells, okay, I'm going to hire him. So computer tell me, okay, whether this person is capable for this job or not. So how this is done? This is done because of factor analytics. So that is the one thing I personally worked in a real time for a real time project. and we applied factor analytics on top of it, and we delivered the project to the customer. So this is the brief overview on how we and where we apply factor analytics in the industry. So since I'm from industry, I have hands-on experience with factor analytics. I'm just explaining you about this so that you'll understand more, so that it will be helpful for you for your future. So that is the main idea behind this one. So being said that, we can tell factor analytics as variable detection technique. So what exactly the variables are? So here we are going to use few terms, like, so we use a term called variable. That means variable is nothing but the field that is used for analytics. That is what we call it as a variable. And it reduces the set of variable in terms of smaller number of latent factors. So I'll explain you about this line in the next slide. And factor analytics is a correlation method used to find and describe the underlying factors that are driving the data values. Okay, so what exactly this line states? Okay, so what exactly what I was telling is like factor analytics is a correlation method used to find and describe the underlying factors that are driving the data value. So what exactly this name implies? So that means I'll take the HR interviewing as an example for this. So what are the driving factors from which I can hire people? So first, yes, I can check with hire or his mannerism, his domain knowledge, his knowledge towards the industry, his technical knowledge, and I can name anything. So I can scale a person, rate a person out of scale from 1 to 10, and I can ask them to do the analytics, right? So these are the factors that are driving the decision, right? So factor analytics is not going to focus on those things. So factor analytics is going to focus on the unobserved factors. So that is what we call it as latent factors. So what exactly those are? It's nothing but, I'll take this as an example. So if you see on the left, we call it as variables. That is the driving terms or driving key items that are used for decision making in the industry. So, or in the use case, I'll make it as a use case. And right side, you can see as factors. So what factor analytics do, or what we are going to do are, so the right side is called the latent factors. So that means,
sir, please share your PPT. PPT is not visible, sir.
Oh, PPT is not visible. Okay, I think
PPT is visible.
Sir, visible, sir.
Visible.
Yeah.
I think that participants' internet may be somewhat not up to the mark. That is, when that. Okay, sir, you continue. PPT is visible.
Okay. I will rectify that.
Okay, sir. Yeah, thank you very much. Yeah. So what exactly this representation implies? Oh, sorry. Yeah. So what exactly this implies is nothing but, as I said, so variables are the driving factors for taking or making decisions for the given use cases. So as we already said, factor analytics is going to propose or is going to derive and we are going to use the latent factors, that is nothing but the unobserved factors. So we are going to take decisions on not only on the left, we are going to take decisions based on the right values. That is what we call it as factors. So from now on, we're going to use the term called factors for the unobserved variables, and observed variables, we're going to just name it as observed variables. So that is what the term we're going to use. So coming back to this one, so as you can see, I can get survey from the end users about the waiting time, cleanliness, staff behavior, taste of food temperature, and freshness of food. So I can get survey or feedback from the users of the restaurant, and based on that I can do factor analytics. So factor analytics, what it does is nothing but it combines the relevant factors into a name, and we can give a custom name on top of it. So that is what the fact analytics does to us. Okay, so as you can see here, this we are grouping these three things, and we are creating custom name for those group called cleanliness. So we are going to apply factor analytics. We are going to group the relevant factors, and we are going to provide suggestions for the given output. That's what we're going to do. So I'll take the HR as an example, HR scenario as an example. So we are getting survey or feedback for each and every round in the industry, and as we can see, we are grouping these things into certain categories, and then we are giving suggestions for the user whether this person is capable for this project or not. So that's how we are going to apply factor analytics. So this is the whole capability of factor analytics is. Okay, so where we can apply factor analytics. So factor analytics is being applied, or it is widely used in market research, advertising, psychology, finance, and operating research. So can anybody, okay, as we know, I explained about factor analytics now. Can anybody quickly tell me how this can be applied for market analytics, market research? So how this can be applied? How this can be applied? Can anybody tell me real quick? Because I just give you a brief intro about how factor analytics is being used in the industry, and in a real explanation I gave. So can anybody tell me where how factor analytics can be applied for market research?
By analyzing the factors with respect to
Analyzing the factors, yes. How what are the good?
Product,
Okay.
the different category wise, like product, environment, like stakeholders of that the business, we have to identify, and based on collecting that factors, grouping that factors, collecting the attributes, then
Great. Okay.
finding that the collection of attributes as a factor, then based on that it will be analyzed.
Okay, got it. Yeah. So one of the people said, okay, yeah. So we can do with the shopper's behavior kind of thing. Yes, yes, ma'am. You're right too. So that is where we are using factor analytics. So as ma'am said, I'll just quickly. Yeah.
Sir, even in sequence analysis, I mean sequence pattern mining, we can apply this factor. Sequence pattern mining is a topic where we can apply factor analysis.
Great, ma'am. Yeah. So that's great. Yeah. So with the help of sequence analytics, so yes, we can apply it. How we can apply? Yes, we have a wide range of values that has values for a given ratio or a range. So based on that, we can group items as a factors, and we can apply factor analytics on top of it. So that's a great answer. So market researchers use factor analytics to identify price-sensitive customers. That's how we apply factor analytics in market research. So we can identify brand features that influences customers' choice, one, and help them understanding the channel selection criteria based on the distribution channel. So as one of the people said in the chat, yes, based on the users selection, users navigation, and yes, and with the help of users channels, and how the brands are featured, etc. So we can apply market analytics on top of it, factor analytics on top of it, and we can get great results as an outcome. This is what machine learning is. So we used to have the term called machine learning. Before this, I move forward, I want to tell you a few things. So when I joined industry in 2011, so we were using machine learning, and many of the projects were using machine learning for so long. Since the technology progressed and the frameworks progressed, so they named those technology and frameworks as machine learning. And nowadays, without machine learning and artificial intelligence, that keywords in the project, we are not getting any bidding. So if we are going for a bid for a project, we have to mandatorily use that word, like regardless of what it is. So we have to mandatorily use, okay, we are going to apply machine learning and artificial intelligence for so and so modules and so and so techniques. So this is how we are going to project the project. So that is how industry is progressing. So as I said earlier, machine learning, this is what machine learning for your project is. So as I said to you at the starting of the presentation, so I worked in a project where I applied factor analytics in real time, and that project was on 2012. So you can think of, in 2012 itself, we applied machine learning to the companies. Nowadays, we are just having the term or a brand called machine learning and artificial intelligence. So that means machine learning, artificial intelligence are there in industry for so long. So we are going to use those techniques, and we're going to apply for different use cases. So coming back to this one, so factor analytics, this is what factor analytics is. So we are going to group certain factors. We are going to make it as unnoticeable, unobserved stuffs. For example, coming back to this one, so here we are going to do the analysis based on factors, not on the variables. So that is what the intention, that is what the conclusion for this slide. So factor analytics, we are going to apply, we are going to get output based on the factors, not on the variables. So being said that, a quick example, second example for factor analytics is nothing but, well, there is a company called Hatco, industrial supplier. So they obtain data from 7 different variables. So what are those variables? So those variables are the delivery speed, price level, price flexibility, manufacturer's image, overall service, sales force image, product quality. So they get these informations from the customer. They ask them to scale it from poor to excellent. So based on those information, so they apply factor analytics on top of that, and they get, okay, the decision should not be in a single factor. For example, I should not take a decision based on delivery speed, but delivery speed and overall service are related, right? So I can group those things. For example, product quality and the pricing level is directly proportional, right? So I have to group those things. I have to do analytics, and I have to take decisions on top of that. So the grouping and taking analytics, that is what we call it as factor analytics. So this is how we apply factor analytics in real time. So another typical example, okay? So to determine the benefits of a toothpaste. So the responses were like, it is important to buy toothpaste to prevent cavities, and these are the different responses for basically these are the variables we are going to measure. So what that implies, we're going to group these variables and going to create factors, right? So that means I'm going to group these variables and I'm going to create factors on top of it. For example, I can group and I can create factor 1. I can create these 2 and create factor 2, and I'm going to create variable 6 as simply factor 3. So I can create like these. So that means this is what the real-time example for your factor analytics implementation is. So these are the other examples. For example, what are the underlying attitudes lead people to respond to the questions on a political survey? Examining the correlations among the survey items reveals that there is a significant overlap. So these are the typical examples. And questions about the taxes tend to correlate with each other. So these are the typical examples, the real-time use cases. Or you can typically use the surveys. We are using surveys day in, day out. For example, at the end of the session, you will be asked for giving feedback about the presentation, right? So what are the variables on top of it? So variables are the quality of presentation, the content of the presentation, and the timing of the presentation, hands-on experience of the presentation, and we have those variables, right? So we are giving a scale of 1 to 5, and how I can apply factor analytics on top of it. I group these things and I combine as a factors, and with the help of factors, I apply factor analytics on top of it, and with the help of it, I'll say, okay, if this kind of presentation is coming in future, so this will be the outcome of it, and this is how people likes it, and these are the factors, that is the uninformed factors, uninformed variables. So that is what we call it as factor analytics. So, and you can ask me, okay, is there a factor analytics alone for variable reduction? No. So there is one more thing called factor analytics and PCAs. So principal component analytics. So so what is the difference between factor analytics and PCAs? Okay. I have only few slides, so I will complete this one and I'll go to hands-on so that you'll understand how we can import the data, how we can apply factor analytics on top of it, and how we can get outcome on top of it to get better decisions. So because without some theorization, without prior knowledge of factor analytics, if you go for hands-on, then you won't get an idea, okay, what exactly we are doing. So that's why I thought I'll quickly have this one. So being said that, factor analytics and PCAs. So factor analytics and PCA. PCA's approach to data reduction is to create one or more index variables from large set of measured variables. That means we have, it is like a combination of individual variables, and they're combined to form a common variable. That is what we call it as principal component analytics. So, but factor analytics is a model of measurement of latent variable. This latent variable cannot be directly measured with a single variable. That is, for example, if you want to measure intelligence of a person, so we rate those intelligent variables from a scale, and based on that we take factor analytics. If you want to understand about social anxiety, and if you want to rate anything, because factor analytics is nothing but rating. So with the help of rating, we are analyzing something. That is what a bottom line information about factor analytics. So I'll quickly skip on few slides because of the time constraints. So factor analytics and PCAs can be grouped like this. So factor analytics is nothing but finding common variance and aligning them as factors. So that is nothing but heat maps. So we always deal with heat maps kind of thing, and we are working on. How about PCAs, principal component analytics? So it is a total variance that is divided in the form of forms based on our desires. So this is what PCAs is. So since we are going to focus on factor analytics, I'm going to skip on explaining about principal component analytics, because that is a different ball game on implementing stuff. And I'm going to skip on this slide also. So we'll quickly see how factor analytics works. The primary objective of factor analytics is nothing but reducing the number of observed variable and finding unobserved variables. So if you see, the observed variables in the previous examples are nothing but the person's capability, the domain knowledge, and etc. And what are the unobserved variables? So unobserved variables are nothing but strength, weakness, and company's fit, etc. So out of those 14 or 15 variables, observed variables, I'm going to create an unobserved variable, and I'm going to provide decisions on or based on the unobserved variables. That is what the factor analytics is. So if you see the restaurant example we created before, the main observed variables are nothing but the time for delivery and the food quality, food temperature, etc. And what are those unobserved variables? Nothing but cleanliness and regarding food. So those are the common in general. If you take English terms, so what are the factors? Factors are nothing but the things that are influencing. So fact analysis, nothing but we are going to analyze the things that are going to influence by combining, by grouping, and then applying analytics on top of it. That is what the fact analytics is. So, and these unobserved variable helps the market researcher / the user to conclude the survey or his or her requirement. That is what fact analytics and how this works. And we can even tell. Okay, so what I was telling is like factor analytics takes two steps. So one is factor extraction and the second is factor rotation. So factor extraction is nothing but calculating the factors out of the observed variables. So and factor rotation is nothing but rotating the factor so that we can get accurate results. So why do we need factor rotation? So that I'll explain you in the future slides. So. So I have only 6 slides, so I'll quickly move on to that one, and I'll start the hands-on stuff. Okay, so we're going to see what are the terminologies we're going to use. As I said earlier, we're going to use a term called factor. So what exactly the factors are? So factors are nothing but are the latent variable, that is unobserved variables. So that is nothing but we are going to group that, and we're going to calculate the analytics on top of it, and we're going to get the results. So that is what a fact analytics is. So the term factor, we call it as latent variables, hidden variables, or unobserved variables. So this is what we call it as factors. So since it's nothing but the terminologies we're going to use. The second thing we are going to is nothing but the factor loading. So factor loading is nothing but a loading or combining or grouping the observed variables and finding the factors. So that's what we call it as factor loading. So factor loading is nothing but it is kind of matrix that gives a relationship of each and every variable based on the different factors we are going to provide. That is what factor loading is. So in simple terms, you imagine, like, so we have list of survey entries, we have the questionnaires, and we are going to group the questionnaires into some name. That name is called factors, and we are going to do analytics or analysis on top of that one by grouping those things, by doing rotations, by doing other operations, and we are going to get some output on top of it. That is what factor analytics is. So, and we are going to use one term called eigenvalues. It's nothing but it represents variations explained by each and every factors to the total variance. So eigenvalues is predominantly used in many of the machine learning algorithms to get the characteristics roots for the given request. So that is what we use eigenvalues. So we use eigenvalues here in also in factor analytics. And the other common things we need to focus is nothing but we have to have commonalities. So this also we'll see in the future slides. So what are the assumptions you have to make while working with fact analytics? It's nothing but there should be no outliers in the data, because it will have false results in your fact analytics output. Sample size should be greater than the factors, because you should have more than one factor, so that your observed variables also should be more than your factors, so that it should be proportional to each other. So and data should be metric in nature. For example, it can be an interval or ratio scale, because we're going to focus on, for example, if you take a questionnaire, it will be like 1 to 10, or it can be like we are going to rate based on the scale, like 0 to 100 or something. So bottom line, it should be numbers. That's what factor analytics is. And variables should be linear in nature. It should not be non-linear in nature, so that factor analytics will be accurate by giving the solution. So, I'm going to skip on this one. These are just for knowledge purposes. So what are the steps for conducting factor analytics. So these are the things we need to know. So we know, yes, we know how we can implement factor analytics for our application. Yes, we know, okay, what is factor analytics, on what factors we can apply factor analytics, how we can apply factor analytics by grouping kind of stuff. So these are the steps for achieving factor analytics. Okay, first is problem formulation. Second is construction of correlation matrix. Third is method for factor analysis, and determining number of factors, rotating, and interpretation. So these are the optional stuff for your factor analytics. This can be sent to the future, or for example, we are doing a research, or we are doing a project. We are going to apply factor analytics on top of some module, and we need to get output, and that output can be used for the other decision making purposes. That can be given as an input for other modules, so that input will be used for massaging few informations and taking some decisions. So these are the optional steps in the factor analytics, where this can be given as a custom input for the other algorithms as like factor analytics. So that is what about factor analytics is. So what exactly these steps are? Problem formulation. It's nothing but we need to formulate a problem, right? So we have data. We need to know what exactly we need on top of that data. So it's nothing but the objectives for the factor analytics should be identified. For the HR example, the objective is we need to find whether the interviewee or the hiree is suitable for the company or not. That is the main objective. And what is the objective for the food example? So objective for the food example is nothing but whether, or what are the, I need to know, okay, what are the factors that is influencing the customer's behavior? So that is one problem statement for that analytics. So what is for the toothpaste and what is for other things you can imagine? Okay, first, bottom line, we have to formulate the problem, and second is nothing but we have to construct the correlation matrix. It's nothing but correlation matrix is nothing but we have to see, okay, whether our data is capable for factor analytics or not. So that is what we name it as. That is what we call. That is what we name it as adequacy test for analytics. That is, I have data. I need to know, okay, whether I can apply factor analytics on top of that or not. Instead of like I have 5 steps. At the end of each step, okay, if it tells, okay, this data is not sufficient for this one. Instead of that, as a second step itself, I will find, okay, whether my data is okay for factor analytics. That is my second step. So, can we found factors in the data set? Without factors, we cannot do factor analytics, right? So, this correlation matrix will help us to find, okay, whether factors are there. You're good to go for factor analytics or not. That is what the second step is. So what is the third step? It's nothing but determining the number of factors. So as a first example, HR, we had 18 observed variables. So out of those 18 observed variables, we have to find, okay, what are things are correlated, and with the help of the correlation, how much factors I can derive on top of it. So that is what we call it as determining the number of factors. Because I have 18 variables, it's not fair enough to have 14 factors, because if I have 14 factors, like it's like one-to-one relation. One factor will have one variable. If that is the case, then we will not have correct accuracy in the factor analytics. So I have 18 observed variable, and consider I have 3 factors. Then I'm grouping 6 variables as a single factor, and I'm going to perform the analytics output. So that is what that is why we need to know, okay, what are the number of factors that can be used for my factor analytics based on the data I have. So first step, we want to determine the problem. Second step, we want to check whether I'm capable of doing factor analytics for my data. Third, I need to find the number of factors for my data. How we can find number of factors? It is like prior knowledge, or with the help of eigenvalues, or with the help of Skiri plot. So this I'll explain you in a real time, okay, by executing the program I'll explain you. And fourth way is, I think, by determining based on percentage of variance. So these are the four methods in which we can find the number of factors. As a prescribed one, so we can widely used steps are eigenvalues and Skiri plot. So those are the two methods widely used among in the industry also. So what is the fourth step? Is nothing but rotation of the factors. So unrotated results form from factor analytics is not easy for the interruption. So for example, if you see here, so we are doing a plot of my factors. You see here, I have only two in the x-axis also, and in the y-axis I have two values. So if you see here, and I already explained to you, like some factors will have majority contribution, and some factors will not have major contribution, so that without that information we cannot provide accuracy in the factor analytics. So for example, if you see here, factor 1, all the variables are higher. Only in out of these 6, 5 are higher, and only one value here is high. So if you take factor analytics on top of this one, because this is unrotated, this is what we call it as unrotated data. If you apply factor analytics on top of this one, so we cannot get adequate results. So to do that, in order to avoid that, what we do is we rotate the values, we rotate the correlation among these things. We shift gears from axes. We do two types of rotation, varimax and oblique rotation. We do these things, and because these two topics is a different, it's a wide range of explanation. Since we have shorter amount of time, I'm just giving you a heads up, okay, what exactly this is, and what exactly we can do, and how we can apply it. That's what the agenda for today's meeting. So so we can rotate the data, we can calculate the correlation matrix in a runtime, and we can find the accuracy so that all the factors are equally distributed, and the correlation among themselves are equally calculated, and with the help of that, the factors are determined, and with the help of that factors determined, we can do analytics and get a better result. So that is what we call it as rotations. So, and the final step is nothing but interpreting the factor. So consider I have 6 variables. I have these are the 6 variables I have. So these are the 6 variables I have, and these are the factors. You see here, these are the factors. These are the variables, and these are the factors we have. So on bottom of that, you can see we have values on the red, right? So those are nothing but those are the high values for each and every factors for those variables. So that means variable 1 is highly influenced on factor 2. Variable 2 is highly influenced on factor V2, and etc. So this is how we interpret factors. So I'll explain you about more about these things in a real time. Okay. So being said that, I'm going to wind off this theoretical session. I'm going to quickly show you how we can interpret data and find, okay, what are the correlations among these things. Okay. So what I'm going to do is I'm going to take a data set. I'm going to take a data set. I took the data set, and this is the data set I took. This is nothing but the flight travel satisfaction survey. So this is the ID, gender, customer type, and type of travel, the class in which they traveled, the flight distances, and these columns. You see here, these columns are nothing but the survey results for each and every customer. And apart from that, we have other informations. So now what we are going to do is we are going to apply factor analytics on top of it and find, okay, how the factors are related, and we are going to see, okay, what are the factors that are influencing the customers for their travel. So that is the requirement for us. Okay. So as a first step, as a first step, we have to define a problem statement, right? So problem statement is nothing but I have the list. I need to know, okay, what are the factors in which the customers are facing difficulties, or it's like what are the factors that are influencing the customers' travel. So and how the customers are feeling based on the travel they have. So this is what we're going to do. Okay. So what I'm going to do is I'm going to I'm just going to use Google's Colab. Uh, can all of you see my screen? This Google Colab.
Yes, sir.
Cool. Okay. So what I'm going to do is first we need to import the data set. So all of you familiar with Google Colab? Because since we have shorter period, I thought I'll run through okay what exactly and how we can apply factor analytics. So all of you familiar with Google Colab?
The last 2 days we are learning with the collapse only, sir.
Okay, got it. Thanks for that. Yeah. So just for a quick running example, so I took Google Colab so that I can run and show you in real time on how we can apply factor analytics on top of the data set we have. Okay. So so first things first. So we need to first load the data set to our project. So to load the data set, I need to import it. So I'm going to drag and drop. It will import the data set. Yes, it's importing. Oh, it is 12 MB. So yeah, it's importing. So first step, we are importing the project, importing the data set for the project. Second, we need to define the problem statement. I'm going to find the factors for the customers on what are the factors like the grouped factors for the customers about the flight journey or flight travel in the as a flight company. Okay, so I'm going to use Python and I'm going to use the MATLAB libraries. I'm going to use pandas for achieving these things. Okay, so as a first step, I'm going to there is yeah as a first step, I'm going to excuse me. As a first step, I'm going to import all these libraries. So first, I'm going to import. Seaborn is nothing but that is used for producing the maps, like heat maps. Okay, so I'm going to use that library, and I'm going to use matplot library. In that, I'm going to use pyplot, and I'm going to use pandas, as I said. And I'm going to use a few libraries like for Python has an internal library for factor analyzing. So that library is called Factor Analyzer. Factor Analyzer. Factor Analyzer. Okay, so to use this one, I need to install that. So I'm going to install that. Yep. Install Factor Analyzer. Okay, so I'm going to run and see whether I'm good to go or not. Okay, there is an error. Oh, sorry. Yes, it's downloading the necessary libraries. So now I'm good to go with my application. So as a second thing, I need to see, okay, the correlation matrix, right? So I need to know, okay, whether my data is okay for my factor analysis. This is my second step. First, I define the problem. Second, I need to see the correlation matrix, right? So what I'm going to do is I'm going to I'm going to apply heat map on top of that so that I can see whether the data is highly correlated or moderately correlated or no correlation between them. So I'm going to run heat map so that I'm going to see the result so that I can somewhat tell, okay, my data set is okay for my factor analytics or not. Okay, so what I'm going to do is I'm going to plot a heat map. So I'm going to define the figure size. Figure size, I can define it as 2010. I'm going to define a variable, and before that, I just need to import the data set. Yeah, first I need to import the data set. So what I'll do is I'll create a variable, and I'm going to import the data set. Like so, I'm going to run this and see. Okay, there is an error. Okay, it's a test. Yeah, so data is imported successfully. So I'm going to now join C. Yeah, so I'm going to draw and see heat map. Yeah, so this is my heat map data out of the thing which I have. So by looking into this one, I can see, okay, so this is the correlation, right? So this is the white box is the correlation among the data I have, that is the x-axis and y-axis. So by this, I can say, okay, yeah, my data is now okay with my factor analytics program. Process. So there are a few things on top of this one. We can say yes, some values are highly correlated, especially the items that are related to survey, because these are the survey, right? The in-flight service to the cleanliness. These are the things that are highly correlated. Yes, sir.
Sir, can I know how to read this heat map? I'm not able to interpret it.
No, actually, sir. Yeah, we. What do you want to know in this, sir? Just want to.
Sir, I want to know like how to read heat map. What is heat map, and how what we can analyze through this diagram.
Okay, so I have a question on top of that one for you, sir. So you know how to interpret the correlation matrix, how to get those information.
Yeah, confusion matrix, right?
Yeah. So that is what heat map is. Like in the correlation matrix, we have like diagonally we have ones, and before the diagonal triangle we have values from minus and plus, and sometimes it will be zero, right? So that is what the heat map is. So actually, this we do it in the industry because the correlation matrix we drive, we provide a correlation matrix. It is not like in a readable form in the industry. So what we do is we convert that into a heat map. So that heat map is nothing but we are going to draw correlation, and we are going to provide heat map on top of that. So that means you see here the diagonal value is white. That is what the value 1 in the correlation matrix. So if we convert that into a numbers, so this is what we term. It will be number 1, and below that it will be the correlated values, like it can be -1, 1.7, 0.95, etc. So it will be the values like that. So we are converting the correlation value to a heat map to see, okay, whether the values are highly correlated or no correlation among that one. So maybe you can learn about that in a separate, because it is a big discussion if you make it. So a quick answer to you is like we converting the correlation matrix into a heat map. That is what it is. Did I answer your question? Okay. Yeah. So so bottom line, we're going to see the correlation between the data. So if we see here, some variables are quietly correlated, some are highly correlated, especially the ones we see in the survey answers. So that means my data set is ready for the factor analytics. So however, what really stands out is the extremely highly correlated informations between the departure in minutes and arriving in a delay. So those are the things. So these are highly correlated. This is like there is highly correlated, so we can exclude that one, because since we are going to apply factor analytics for only the ratio or values that are having numbers. So we are going to use from this the in-flight service to the cleanliness. So we're going to take only these factors, but bottom line, this heat map suggests, okay, I'm ready to go with my factor analytics implementation. So bottom line, to answer the question, so we are converting, it's like from the code itself you can see. So if I print this one, if I print C, if you print C, you can see values like this. So what we are doing is, instead of printing like that, we are going to print it in the form of heat maps. So this is like the correlation values. So with the help of a heat map, we are just representing that in a way so that we can understand better by looking into the heat map itself. Basically, the correlation between the variables, we can see it in the heat maps. So since the values that are having the survey values, we're going to focus only on survey values. So I'm going to remove these columns. So you know about Google Colab, and you know about Python implementation. So I'm just going to explain about a few things quicker, so that it will be giving an idea on how we can implement uh, uh, factor analytics with the help of a data set. So you can learn about this code later. Maybe I can share this code to you. You can implement yourself in Google Colab, and you can play around with this one, and you can take it forward. Okay, so the next step is, like, I need to remove those columns. Like, I don't need the first 3 columns and the next 2 columns, because those are not related to my factor analytics. So what I'm going to do is, I'm going to remove those columns, and if I print the column names, we can see whether the columns are removed or not. So if you see here, yes. So the other columns are removed, and from in-flight service to the cleanliness, I have data, and the other 2 columns are also removed. So the next step for all the machine learning algorithms that are related to the numbers, something but dropping the missing values. So sometimes, for example, if the values are missing in the rows, we're going to remove that one too. So this is the command to remove that one. And so I'm going to see, okay, what are the columns we are going to focus. So command for is like columns dot size. So it will tell, okay, what are the columns we have, how much number. Okay, so this means I have 14 as the column size. So that means we are having defined variables, observed variables. I think what the 14. So these are the observed variables. For example, from in-flight Wi-Fi service until cleanliness, these are the observed variables for our implementation. So what we're going to do, the first step is we created the requirement. Second, we checked about, okay, whether I'm matching with the correlations or not. Third, what is the third step? It's like I need to determine the factors, right? So what I have to do is, so for determining the factors, there are 2 methods. So no, for determining the factors, we have only one method. So the program for command for determining the factors is nothing but, I'm going to create a variable factor. So factor analyzer is nothing but, this is nothing but the inbuilt package that is inside the Python. We're going to use that factor analyzer package, and we are going to check, okay, how much factors we are going to use, right? So to find the how much factors we are having, so as I said, we have 4 methods. One is like with the help of domain knowledge. Second is like getting the variance. Third is nothing but with the help of eigenvalues. And fourth is with the help of chart, right? So we are going to skip on the first and last one. We're going to use the eigenvalues to determine how many factors we have, and we are going to see with the help of scary plot, we're going to see how much factors we have, right? So with the help of eigenvalues, we'll first see how we can determine the factors. So with the help of this command, yes. So if you learned about eigenvalues, because eigenvalue topic alone is a bigger discussion topic. So as a short thing I can explain you. So eigenvalues is nothing but I run certain calculations, and to determine the eigenvalue outcome, we have to consider the values that are greater than 1. That is what the eigenvalue results speak. So for eigenvalue calculation, this is what the eigenvalue calculation for the data set I have. So with the help of this one, this says, okay, values that are above 1 are nothing but the factors, right? So I have 1, I have 2, and 3 factors. Okay, so for the given data set, with the help of factor analysis, I can tell, and with the help of eigenvalue calculation, we can tell, okay, we can apply 3 factors on top of this data set for the analysis. So this is one step, one type. We can find the number of factors for factor analysis. Second step is nothing but with the help of scary plot, right? So how we can do scary plot? With the help of MATLAB plot library. So I'm going to just paste that code and run it. You see here, this is if you know MATLAB py plot libraries, you will understand, okay, what exactly this command is. But bottom line, I'm passing the data table value, and I'm calculating the scary plot. So what it says, okay, more than 1. With the help of more than 1 value, I can determine number of factors. So with the help of this chart, you can see more than 1, we have 1, 2, and 3 values. So both the results, eigenvalue result and my scary plot results, suggest that, okay, I can use 3 factors for my implementation for the given given data set. And the final step is nothing but we are going to determine the fact analytics on top of the data set. So first step, I determine the requirement. Second, I just checked whether I can able to do fact analytics with the help of correlation matrix, and that was projected in the form of heat map. And a third step is to calculate the factors that are determining the fact analytics. So we did it with the help of eigenvalues and with the help of scary chart. So those are the 3 steps. And the fourth and final step is nothing but the calculation of fact analysis. So how we can do fact analysis? Nothing but it is very simple. So again, I'm creating a variable. So factor analyzer, and I'm going to set params. To the podium, I'm just telling this is just a programming stuff. So this is just a programming that supports the fact analytics. So to support Python for this one, we have to run this command. So this is just an outcome. Since I'm from industry, I can able to easily visualize, okay, what exactly these are. And we're going to pass the factors. So we're going to tell, okay, do these to perform this fact analytics. Sorry.
Sorry.
Okay, yeah. So to do the analytics, fact analytics, first we have to define the number of factors. We have to pass that number of factors to the program, and we have to give the rotation. So second is nothing but rotation. So as I said earlier, we have oblique rotation, and we have a normal rotation. So normal rotation is called as varimax. So if you learn about fact analytics in depth, you'll understand what exactly the varimax, what exactly the rotation is, and how rotations are taking place, etc. So the rotation here we use is called varimax, and we're going to fit the data, and I'm going to So what are things I did here? I initialized the variable. Second, I passed the parameters like number of factors and the rotation type, and then I'm doing fact analysis apply for the given data set. So df is nothing but my data frame, right? So I'm passing the data frame with the help of 3 factors and rotation matrix. That's it. So Python will take care of all your fact analytics process. So if I run this one, we can see these are the factors. Okay, so you can ask me how I can say, okay, these are the things we are going to focus, and how I can decode this data. If every decode content, then you can ask me, okay, how I can decode on top of this one. There's nothing but I'm going to have one more command. So this is my output, and I'm going to open one more command, and this will give, okay, what are the columns I have. So starting off from this one, for in-flight service, factor 1, factor 2, and factor 3. And for dispatcher service, I have factor 1, factor 2, and factor 3. So this is how my values are correlated. Okay, so how I can interpret this one. So you see here. So what is the maximum value for factor 1 for I need to find, okay, what are the factors that are influencing, what are the variables that are influencing the factor 1, right? So maximum value out of this one is like we have 851, 1, 2, and we have 3 factors, right? So what is the cleanliness? And you have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, seat comfort, in-flight entertainment, and cleanliness are the factors that are influencing the factor 1. So maximum out of these factors are nothing but, so what I can tell, I can create I can tell, okay, as a outcome, what I can tell is like factor 1's contributors are cleanliness, seat comfort, and /drink. Okay, so factors 2's things are, this is factor 2. What is the maximum value? It is line number 12, 10, and what is the other one is baggage handling. Yes, so I can it's like maximum, I have 3 factors, so I need to find the best fit for the particular factor. So the factor 2's things are onboard services, then baggage handling, and in-flight service. Okay, and the factor 3, if you see, like the third one, first, third, and fourth. So those are the 3 things, right? So in-flight Wi-Fi, online booking, and gate location. So those are the factors, right? So factor 3 is nothing but in-flight Wi-Fi.
Excuse me, sir.
Online. Yes, sir.
Last 5 minutes. Okay.
Yes, sir. Yeah, I'll wind off. Yeah. So yeah, if you see here, I have these many factors that are inside my application, inside my data set. I had applied factor analytics on top of that, and I found, okay, these are the factors that are influencing this one. So I can rename this one as a factor. This I can rename it as comfort. Second, I can combine it as service, and I can make it as convenience. Okay, so as a flight company, if I see this output in the application, as a flight company, if I see this application output, I can tell, okay, people are happy with the help, with this comfortness, service, and convenience that we are providing. And if I want to dig a little deeper, okay, what are the comfort they are preferring? One is cleanliness, seat comfort, and food and drink. They are happy. And what are the service they are happy? Like onboard, baggage, and in-flight service, they are happy. And what is the convenience they are happy that they are providing? It's in-flight Wi-Fi, they are happy. Online booking, they are happy. Gate location, they are happy. So with the help of, out of these 14 elements, 9 elements are given with high ratings, so that I can tell, okay, company, okay, I can improve my this thing much better. And as a customer, with the help of this, company provides better services, and I'm happy with the service. So this is where we apply factor analytics on top of it in the real implementation and in the real industry. So any doubts on top of this one? Because it's a wide topic, just 1.5 hours is not sufficient for this one. I try to manage these things so that I can help you in understanding, okay, what exactly the factor analytics is and how we can apply factor analytics on top of this one. Maybe this is a heads up for you or to take it forward, like what factor analytics is, how we can use factor analytics, how we can use data set, how we can implement it in a real time, and how we can get output, how we can determine the output of the factors which we have, and how this can be used in real time. So these are just a quick agenda of my my discussion for 1.5 hours. So any questions on top of this?
Thank you, sir. Very nice presentation. You are energetically presenting. I am very happy.
Thank you very much, sir. Thank you. So any doubts on top of this one? Actually, I gave an explanation in the industry point of view, so that you can understand it better with the real implementation. That's why I gave like that. So any doubts on top of that, like, or any feedbacks, comments?
Shall we call this as another version of classification? So in that classification, we are classifying that attributes, then predicting based on it.
Yes, ma'am. Yeah, it's like yeah, you're right. It's almost another form of classification, like
classification, like yeah.
That's right. That's right. Yeah, yeah. It's like we are classifying something. So we are classifying the factors. Here we are classifying the factors.
Like here we are calling the dozen factors.
That's right. That's right. Yeah.
Yes. Thanks, sir. Thank you, sir.
Yeah.
Good morning.